transition curve. The transition curve, we are going to discuss about it. So what is the transition curve? Transition curve is simple. It is the curve which is provided in the transition between the straight line and the circular curve. This curve portion is known as the transition curve portion. All right, this curve portion will be transition curve portion. It is provided at the uh, at between the two curve portion, and it is known as the transition curve portion. So what is its objective? Its objective is, first objective is to introduce gradually centrifugal force between the tangent point and beginning of the circular curve, avoiding the sudden jerk on the vehicle. This increases the comfort. Obviously, to increase the comfort, the transition curve is provided between the straight portion where the radius is infinity at this portion, and the desired radius will be in the circular part. And we provide the transition curve in this portion so that there will be gradual application of centrifugal force. Thus, if we provide if it doesn't provide the this transition curve, then after the straight curve, the automatically the centrifugal force will act in very rapid way, so that the driver can feel much discomfort, the passenger can feel much discomfort. The driver, look, at the second point we have written as to enable the driver to turn the steering gradually for his own comfort and security. So if we provide suddenly the circular curve, then the driver need to put a lot of effort on turning up the steering wheel. So that will cause a security threat as well, because the maybe the vehicle will not turn properly. And the next one is gradually introduce the design. We know that super elevation is provided along the length of the curve. So from straight portion to length of the curve, we need to provide the transition curve, and in this portion of transition curve we provide super elevation gradually by those two methods we had discussed earlier. Okay, and we gradually we also start providing the super elevation from here, and it will be like this. Okay, and another is the aesthetic appearance. The road should be beautiful as well, because the transition curve make the road beautiful. So we design the length of transition curve by three method. What will be the length of transition curve? And we design this length of transition curve by three methods. So the first method is rate of change of centrifugal acceleration. What do you mean by centrifugal acceleration? Centrifugal acceleration is v square by r. That will be given by the centrifugal force. So in this we have written as radius is 0, radius is infinity, and centrifugal acceleration is 0. Radius infinity means acceleration will be 0 at straight portion. Okay, and at the end of the transition, radius has a minimum value, because the curve starts to proceed at the end of the transition curve. So the radius will be at a desired value. Okay, and radius will be some value, that is r, and centrifugal acceleration will also have some value, that is v square by r. And is comfort minimum value, low rate of centrifugal acceleration develop, which causes the discomfort to the passenger. Larger the length of the transition curve, low the rate of the centrifugal acceleration introduced. Okay, it's nothing explained here. So if c is the rate of change of the centrifugal acceleration, then what will be the maximum centrifugal acceleration that is produced? That will be b square by r, which would be on the circular curve. So final maximum centrifugal for acceleration minus minimum centrifugal acceleration is at the beginning of the centrifugal curve, that is 0. And which length will it be provided? It will be provided along the length of the transition curve, because may consider this as the length of transition curve. This is straight portion, so here acceleration equals to 0, centrifugal acceleration is 0. And here after this the horizontal curve will be provided. So here it will have the desired value r. Obviously in here also the value will be r. So maximum value of centrifugal acceleration is v square by r in this portion. So maximum value is v square by r, minimum value is 0, and where it is provided? Along the length of the transition curve. So what will be the rate of change of centrifugal acceleration? That means final acceleration minus initial acceleration divided by time. So time will be between this to this. If the design speed is v, then time will be length of curve divided by design speed. This is very simple formula. Okay, so length of curve divided time is substituted by ls divided by b, and it will be written here, and the final value will be b cube by ls into r. And for b to be in kilometer per hour, the this final output will be b cube by 67 ls into r. And the next this c is also given by the empirical. C is an empirical formula which is given by the IRC, that is Indian Road Standard. So C equals to 80 by 75 plus B, where B will be in kilometer per hour. Okay. And after we compute the value of C, then if we exchange this, LS will be B cube by 67 CR, and C value can be computed from this, and radius is already given, B is already given, so we can determine the LS from this method. So let's now move on to the next method, that is the rate of introduction of super elevation. Super elevation means the lifting, raising of the outer edge of the curve with respect to the inner edge, and it is given by, if this is outer is E and B, then theta is the super elevation, so E equals to E by B. Okay, this we have explained earlier as well. And if this rate is, well, let's move on to this figure, which is very clear. So this is the straight portion, and we are providing a what we say, camber in this portion. Okay. So and along this length, so I move along this length towards the transition curve. This is the length of the transition curve, and at this portion, this is the, what we can say, this is the horizontal curve, and this is towards the length of the transition curve. This is the length of the transition curve. This is the length of the transition curve, and at this portion, it is the horizontal curve. Horizontal curve. Let me. This is the horizontal curve. Okay, and what will be this? This is E. That is super elevation, and gradually the age of the camber portion is increasing. This will be outer portion, this is inner portion. Okay, so this is increasing, and what rate it will be increasing? What is this? This will be 1 by n. What, at what angle? The gradually increment of the super elevation outer edge is provided, that is 1 by n. Okay, so in this triangle, tan alpha, well, tan alpha be the value, then it is given by E. E means the outer edge. As I explained earlier as well, this is E and this is B and this is super elevation. So this is E, and the super elevation is provided along the, this is not clearly shown. So the super elevation is provided along the length of the transition curve. So this is LS. So tan alpha equals to E by LS. Tan alpha is given by 1 by n equals to E by LS. And if super elevation is provided by, you can say, rotating the pavement about the inner edge, that means like this, about the inner edge the super elevation is provided, then then there will, the LS value is not divided by 2. That means well, this what you can say, this W plus WB is not divided by 2, because it is provided along the whole length, that is W plus WE. The super elevation is provided along the whole length. Okay, but in case of central line rotation, the super elevation is provided at half the int, that is W plus WE by 2. That's why if the central line rotation is given, then LS equals to divided by 2. If not given, then LS equals to, and you can look E. What will be the E? What is value of E? E equals to E by B equals to E. Then E will be E into B. B means the width of the pavement. Width of the pavement is W plus WE. If extra widening is also provided, then E into W plus WE divided by LS will be there, and LS will be NE W plus WE. Okay, like this we can do. And another one is, the last one is the IRC recommended empirical formula, that will be LS equals to B by 9.5 under root of R. This is the numerical for the transition curve, and let us solve this numerical. Okay, so I explained that the length of the transition curve will be derived from three formulas, three different methods. That is, first one is the rate of change of centrifugal acceleration, and the value will be L equals to B cube by 67 CR. Another one is by the rate of introduction of the super elevation, that is NE W plus WE, and the last one is the length, which is recommended by the IRC, that is B by 9.5 on the root of R. No. I think this is not the length of transition curve that is recommended by IRC. I'm sorry for that. I explained in previous video as well that this formula, but that is not the formula. It is B square by R for hilly terrain, and for plain terrain it will be 2.7 B square by R, where B is the velocity in kilometer per hour. Okay, so in this three method, whichever one the value of LS will be more, we will take that value. So let us start from the question. So What is the question? The radius of the circular curve of a two-lane highway with a design speed of 70 km per hour is 220. So B is given, and we are given as radius of the curve is equals to 220. Assuming extra widening is not necessary, W equals to 0. Okay. So two-lane highway means what is the width of the pavement? That will be 3.5 into 2, that is 7 meter. One highway, if the width of the each highway is 3.5 meter, that we have explained in the cross-sectional area as well in first cross-sectional element. And calculate the length of the transition curve and shift of the curve. We need to calculate the length and the shift. Okay. So let's move on to the question. So at first, what will be LS? LS would be uh, B cube by 67 CR. For it, C need to be calculated. C is given by the empirical relation 80 by 75 plus B. So 80 by 75 plus what is B? B is given as B equals to 70. Okay. So 70. So what is its answer? 0.55 meter per second square per second, that is meter per second cube. So length LS equals to 70 cube divided by 67 into 0.55 into radius is 220. So the answer will be 61 meter. All right. And the next one is from rate of introduction of super elevation. LS equals to NE W plus WE. So we need to calculate what is E. We need to calculate the value of E. The super elevation is not given, right? So how we calculate the value of E? E value is calculated by B square by 2. Always assume that it is a mixed traffic and continue the calculation. Okay, so that it will be much more easier, because in mixed traffic we consider as the velocity will be 0.75 times B. So we decrease the velocity, and that's why a factor of safety is introduced while solving this question. So consider the velocity lesser, and from this we can get the velocity as a super elevation at 0.1, which is greater than 0.07. So we need to provide super elevation at 0.07, and F equals to B square by 127 R minus super elevation. So for this we will be getting F equals to 0. It will be calculated. Okay, so the value obtained is 0.105. So 105 is less than 0.15, so F is okay. So we will be providing E equals to 0.07 and F equals to 0.105. Otherwise we need to decrease the design speed, but in general in the transition curve the design speed decrement is not given. Okay, so what will be N value? N value is generally assumed as 100, 1 in 100 to 1 in 120. Generally, always consider 1 in 100 if not given in the question. So 100 into 0.07. What is the width of the pavement? That is given as 7, and extra widening equals to 0. Sometimes extra widening can also be assumed to be there. So you have to calculate it that way. And what will be the value of LS? The value of LS will be 49 meter. If we solve this, the value of LS will be 49 meter. And the third one is the IRC recommended, and it is given as LS equals to 2.7 B square by R, where the this is considering it as a plain terrain. Is it given in the question which terrain is there? No. So consider it as a plain terrain, and the value will be R is given B equals to 70. You can keep B equals to 70, and R is also given. So the value of the transition curve is and the value will be 60.14. So among these three values, 49 meter, 60.14 meter, and 61 meter. So which one is the biggest? 61 meter. That's why LS equals to 61 meter. And we have to calculate the shift as well. So shift equals to LS square divided by 24R. So it will be 61 square divided by 24 into 220. And the value of shift will 0.70 meter. Okay. Let me write here. The value of the shift will be 0.70 meter. You can calculate it like this. So let's moving on to the next question. This is very important question. This is one of the important question that is that will be asked from the transition curve. Okay, so the national highway radius let us consider radius of the national highway is given as 525 meter, is to be set out to connect the two states. Two states is need to connect. That means one state road, another state road. In between there is a circular road, and in here it is a transition road. Okay. The maximum speed of the vehicle equals to 90 kilometer per hour is the maximum speed. What will be the length of the transition curve? So we need to calculate the length from this three formula, that is b cube by 47 cr. So for that, c equals to 80 by 75 plus v is given as 90. So what will be this value? The value will be 80 by 75 plus 90 equals to 0.48. Okay. Or the value of c is given in the question, that is this is 0.53. The value of c is given in the question. Okay. 0.53 meter per centimeter second cube, 0.52 meter per second cube. I'm sorry that the question is not visible. So meter per second cube is the value of c. Otherwise you can find the value of c as well like this, but if it is given in question, then use the value in the question. So 90 cube by 47 into 0.52 into r, radius is given as 525. So what will be this value? It will be 57 meter, near about 57 meter. Okay. And in second part, we need to calculate according to the length of introduction of super elevation, and we consider that the super elevation is provided by the by rotating the inner edge of the pavement. So W plus W. So what is the value of n? It is given in question. The value of n. The value of n is not given in the question. Okay. So we assume the value of n to be 120 meter. We assume the value of n to be 120 meter. And what is super elevation? Super elevation is provided as v square by 225 r. So b is given as 90 square divided by 225 into what is r? 525. So what will be this value? It is 0.069, which is less than 0.07. So we assume 0.69 as the value of e. Okay. So we need to calculate the extra widening as well. So extra widening is equals to nl square divided by 2r plus b by 9.5 on the root of r. The value of n is 2. It's given in the question. National highway means the length will be 2. Okay. So what is the length? Length is the wheelbase length. It is assumed to be 6.1 meter, and 2 into 525 plus b equals to 90 divided by 9.5 on the root of 525. And on solving this value we get 0.48. So let's keep the value of e and w in this question. So 120 into 0.069 into what is the value of w means 2 lane highway, so 2 into 3.5, so that is 7 plus 0.48, and the answer would be 62 meter. On solving this we get the value of ls as 62 meter. Let me highlight this two value. Okay. So that further I need to check upon which value I need to calculate. Okay. So let's move on to the next one. So the third portion is from the IRC recommended, that is ls equals to 2.7 b square by r. Considering the plain terrain, rolling terrain or plain terrain, so 2.7 into 90 square divided by 525, and the value of ls will be 42 meter. So we add up the maximum value, that is 42, 62 and 57. So we add up as 62 meter. So length of the transition curve is 62 meter. Okay. Now a shift of the circular curve equals to L square by 24. That is 62 square divided by 24 into 525. And the value of this is 0.31 meter. 0.31 meter. So we calculated up here. So we have calculated the length of the transition curve. We calculated the necessary shift. And now we need to calculate the changes at the beginning and end of the curve. We need to calculate the changes at the beginning of the transition curve and the end of the transition curve. And given that the angle of intersection, what is angle of intersection? Simple. Okay, let me explain here. So what is angle of intersection? So we know that this is the changes. Okay, and the transition is curve is provided like this. this is the circular curve, and this is the another transition curve that is provided. Okay. This is the circular curve, and this is the another transition curve provided. So the value up to this is ls by 2, and the value of 2, yeah, this is ls by 2. Please don't go towards the dimension. Okay. And this is the angle which is subtended by the circular curve, let it be del s. And this is the angle which is subtended by the whole transition curve, let it be del. So we know that from the circle properties, del will be equal to this del deflection angle, and the angle of intersection is this value. So it is given as, what is it given? So it is given in the question, and it is 100, look, 130.30 degree 24 minute. So 130 degree 24 minute is the value. So what will be the value of deflection angle? It will be 180 degree minus 130 degree 24 minute, and the value of this would be 49 degree 36 minute. Okay. So we know the value of delta. So let's move forward. So we need to calculate the changes at the intersection point. This point is also given, right? The changes, look at the changes at the intersection point is 192.5 meter. So this is 192.5 meter, and we need to calculate the changes at the beginning of the curve. That means this portion, and we need to calculate the changes at this portion. So our actual path is from here to here. The path is moving along this curve. Okay. So for calculating the changes of the end of the curve, we need to add the length of the transition curve plus the changes of the beginning of the circular curve. Okay. So the main, you can say, target of this question is to find these 2 point changes. First one is this, and the second one is this. So how you calculate this changes? This is the tangent length, right? This is the tangent length up to this length. This is the tangent length. So tangent length is given as r plus s tan delta by 2 plus ls by 2. We are given as delta equals to 49 point degree 36 minute, and ls we calculated as in the previous portion. We calculated ls as where is ls? This is ls, right? So the ls is 62 meter. Okay. So ls equals to 62 meter, and radius is given as this is 525 plus, what is s? S is given 0.31. We calculated it 0.31 into 10 49 degree 36 minute divided by 2 plus 62 by 2. It will be 273.3 meter. Okay. And spiral angle, what is spiral angle? Spiral angle is this angle. So this is we know that this is spiral angle. This is ls by 2. You can see here, this is ls by 2, and this is radius r. Okay. This is radius r. So the what will be the spiral value of spiral angle? So spiral angle equals to ls by 2r. So let's calculate the spiral angle. Spiral angle equals to ls by 2r. So what is ls? Ls equals to 62 divided by 2 into 535 into, this will be in radian. We need to convert the radian into degree. So 180 divided by pi. We convert this into the degree, and we will be calculating this value. So what will be the value of phi s? It will be 62 divided by 2 into 500 into 180 divided by pi. So the value will be 3.38 degree. So what will be the value of del s? Del s is the angle subtended by the circular curve. That means this value, this angle. What will be this value? So del s equals to delta minus 2 phi s. Okay. We can see here, this is phi s, and this is as well phi s. The angle this, the angle this, and this whole angle is delta, right? So delta minus 2 phi s will be this value. So delta equals to 49 minute 36 minute minus 3.38 degree. So what will be this value? So the value will be 46 degree 13 minute 12 second. All right. Now we need to calculate the length of the circular curve. So length of the circular curve is pi r 46 degree 13 minute 12 second divided by 180. So on calculating it, what will be the length of the circular curve? So what is its length? The length is 423 point. Mm, no. This should be multiplied by 2. Okay. 49 degree 36 minutes minus 2 into 3. I'm sorry for that. So the value is not this. The value will be 42 degree 50 minute 24 second, and the value will be 42 degree 50 minute 24 second. So what will be the value? 42 degree 50 minute 24 second. So the value is 392.54. Okay, 392.54 meter is the value of LC. That is the length of the curve. So what will be the length? Total length. What will be the total length? What is total length? So let's move on to this diagram and let me show you what is the total length. So total length is from here. This green portion is the total length. So what is up to this length? This is LS. And what will be the value of this length? This is LC. And what will be the value of this length? This is also LS. So what will be the total length of the composite curve? So total length of the composite curve is 2 times LS plus LC. That is 2 into 62 plus 392.54. And the value will be around 517 meter. Alright, the value will be around 517 meter. So changes at beginning of transition curve. What is the changes of the beginning of transition curve? Beginning of transition curve changes will be changes at IP minus tangent length. Okay, changes at IP is given as 192.5, and the length of this transition curve is, what is the length? Length of the transition curve is 273.3 meter. Okay, so this is 273.3 meters. So what will be the changes of the beginning of the curve? That is IP. IP means 192.5. You know about the changes. Okay, I'm not explaining what do you mean by the changes. Changes means simple. It is measured from the reference to this point. So if it is 0 and we are measuring from this 0 reference, then, and this is IP, then this whole distance equals to 192.5 meter. And the curve beginning is somewhat here, and we are given as this distance as 273.7. So we need to find this distance. So what will be this distance? We have to minus this from here. So that is basically changes is like that. Okay, and if the changes is given as 1 plus 000 meter, then it means 1000 meter. Okay, this also need to be, if it is like 2 plus 725, then it is given as 2725 meter. Like this the chain is will be like this. If you are confused about the chains, then the question is okay like that. So what will be the changes at the beginning? It will be 818.77. So what we calculated? We calculated the value at this portion. Let me show you from the black marker. So this portion our value is computed. So we need to add this value towards the length of the composite curve, that is all this portion, so that we can get the value of the changes at the last portion. So okay, let's go and compute the value. So changes at end changes will be 818.77 plus length of the composite curve. What is this length? It is 517 meter. So 517 meter, and the value will be 10336 meter. Near about 136 will be the value. Okay. So like this, the numerical is finished, and we'll be explaining further what are the side distance. We'll be reading about the side distance in the next chapter. Next video we'll be learning about the side distance.